On the HMI, we can do Somatic WinCC version 12 basic. We'll cover the basic panels. Those are the low-end, cost-wise, low-end of panels. And if you have a need for a small HMI application, or one that's not going to be high horsepower app, be one you definitely want to talk to your C&E sales rep. The pricing is pretty staggering on those panels. If we move up to a higher level of panel, it's the comfort panel, and that's actually in a widescreen format, which capitalizes on screen technology today, which gives you more power and less money to purchase the screen. Advanced is where we get into a PC-based HMI, and then professional is our actual SCADA application. What is also new that was released along with the 1500 software version 12 is Start Drive, and what that's going to allow us to do is develop the HMI or the actual VFD or the drive right in the project. Something we couldn't do before. We always launched a separate software. This is actually going to be built into the portal software. So when we integrate the PLC HMI today, you'll see the power of having those products integrated and how well it works together when it's in one package. WinCC V12, just to clear it up a little, WinCC Basic covers these basic panels, and those range from 3-inch all the way to 15-inch. Each panel is a touchscreen. The 15-inch is touchscreen only. All of these other panels actually have keypads as well. And then if we want to program the higher-end panels, the multi-panels, which is the traditional line, or the newer comfort panels, we get into WinCC Comfort. And then WinCC Advanced, again, is the PC-based panels. WinCC Professional is the SCADA. And I'm not spending a ton of time on the marketing info, but I wanted to give you guys a little overview of where these products sit. This will be a little bit of a teaser for version 12 slash the S7 1500. We don't have the ability to put the hardware together for this particular webinar. However, we do have a show next week, and you may have seen it on the opening PowerPoint in Kokomo, where we are demonstrating the S7 1500 as well as the software that generates the S7 1500's programming. You'll hear it referred to as TIA Portal, or Step 7 version 11, or Step 7 version 12. They kind of get interchanged, but essentially TIA Portal is the software we're using. One of the things, just a little teaser that I like on the new package, version 11, is the ability to do a couple of online functions. One would be to do a complete program upload without having any program offline. And when I say complete program, that includes all the tag information, all the comments, descriptions, everything. It does not include hardware configuration or network config. However, if you walk up to a machine and you need to pull the program and see what's going on in that machine programmatically, you can do that without having a program prior to that point. As far as generating a backup to protect yourself, you can do also a backup, which is different than the upload of the program. This is actually an upload of everything. And again, you don't need the original project to perform this backup. This file is essentially a backup file that is meant for a recovery point. So this is a way to say, okay, I've got a backup as of May 9th, 2013. I have a problem in June. I can drop this program back in and know that I can get back to this point. Just a little bit of a snippet on what the software is going to be able to do. And then this is a look at the 1500. Many of you have probably not seen the 1500 yet. This is the new PLC. The first time I saw it, I thought it looked like a VFD. And it kind of does look like a VFD. The functionality is quite different and quite advantageous over things we've used in the past, PLC-wise. Really taking advantage of some modern technologies. Probably my favorite single feature on the PLC is probably this display. I can set IP address. I can view IP address. Additionally, I can actually get a PLC here, the SM1516, that has 2 internet cards, network cards, on the PLC. One for plant connectivity, one for your machine I/O network. And that's a rather large benefit, and the connection from plant network to the PLC is actually firewalled at the PLC, meaning we're protecting the PLC from any viral attacks. I can, of course, lock out the ability to change IP addresses as well. Huge feature, system diagnostics and user alarms. We can actually display those right on the HMI or right on this little HMI panel on the PLC. This next feature, module status for central and peripheral modules, used to be I had to get online with the PLC via hardware configuration to see what basic faults were occurring in a module or in a distributed I/O module. That now is appearing right on the panel of the PLC. Very large benefit for maintenance or even engineering for that matter if you don't have a laptop with you. You can pull firmware numbers. This menu, this set menu can be actually multilingual. You can pull and plug this display without interrupting the PLC, and eventually we will be able to remote mount this display on a panel, so it won't actually be right on the front of the PLC if you would like to remote mount it. And this feature we're going to explore a little bit today, show how this works. And this is the integration of system diagnostics and alarm function. This is where I'm going to take my hardware configuration, generate alarm data, and strictly configuration, configure that in system diagnostics, a couple of checkboxes, pop over to my HMI, a couple of checkboxes in my alarm view, and I'm going to be able to pull all the diagnostic information. So if I have node 27, drop voltage on a power module, it can tell me exactly that. Node 27 is drop voltage on a power module, and it will give me the name of that node. So if I've named it, that's junction box 30, it'll come back and say junction box 30, power module, slot 6. So to give me all of that information without having to do any programming, strictly configuration. And we'll look at that today. But the advantage the 1500 brings in is that it takes that diagnostic that we're already getting essentially for free, and it doesn't just display it on the HMI here. It also displays it in a web server. So if we enable the web server on the 1500, we can see the same diagnostic information, as well as turning it on right here on the CPU display so that it shows up right here on the CPU. Really well put together, big time saver for the programmer. And this is a little snapshot of what we're going to do. We're going to add a PLC to a project, integrate the HMI, so add an HMI and integrate it with the PLC, create a very small PLC program, integrate that with the HMI, and then we're going to go ahead and show the system diagnostics that I just mentioned. And then one more feature that I didn't really touch upon, and that is the library functionality. Show how we can create a library and take any object in our program, whether it's configuration or programming, drag it into a library and use it in a future project. So that being said, I'll pop over to the software. So we should be seeing now, and I'll start from scratch here. We should be seeing version 11 software. So here's TIA Portal V11. I'm going to open up my software. See the most recent projects. So I will start with a project from scratch. This is the portal view of version 11. So I will select Create New Project. So give it a name. This will be Rev 3. Now this portal screen is designed to step you through the initial configuration. So we can always pop over to what's called the project view, and that'll look a little more like a traditional project. But we don't have to do that initially. We can simply stay right here in the portal view. My next step, configure a device. So I will click on Configure Device. Select Add New Device. And then you'll see my options here. I can add PLC, I can add a PC, I can add HMI. And if I had my version 12 running, which actually I do have, you would see the drives down here as well, which right now are limited to the G120s. So I have an S7 317 PLC. So expand my S7 300 folder, pop down to S7 my 317F 2PNDP. It is an F, a fail-safe CPU. Select the PLC. By default, it will select the latest firmware. This one is a little bit older, so I'm picking the appropriate firmware, and select Add. Okay, so we're into the device configuration view. It launched us over to the project view. So if I wanted to go back to that portal view, I can click this hyperlink on the lower left. And right back to the portal view. But at this point, I'm going to stick to the project view. And here's my CPU. There's my mounting rail. No modules configured at this point. If I look at the CPU properties, I want to see the properties appear down here in what we call the inspection window. And this is going to be consistent. Any object I select in the device configuration, I will see its properties in this inspection window. So I'm going to pop down here, take a look at a couple of these. So for instance, what do I want the clock memory byte to do? If you're familiar with Step 7, this was a feature in Step 7 Classic as well, where I can turn on this clock memory. On the newer PLCs, I actually have an entire system memory byte that gives me first scan bit, always on, always false, some nice pre-configured bits that typically you add to every program as well. This clock memory is actually a pulsar that gives you 8 different pulsars at different time intervals, 50% duty cycles. So if I needed a 1 second pulsar, 1 second on, 1 second off, then I can enable this clock memory byte, and that happens to be an M0.5. Additionally, system diagnostics. This is the feature that's going to turn on all of my alarming and annunciation for every device in my project and allow me to simply check this box. And when I check a box in the alarm view on the HMI, I'm going to get all of that diagnostic data without having to do anything extra. If I want to, for instance, set up the IP address of the PLC, I can actually select right on the Ethernet port, select the Ethernet addresses, add a network to my project, and I'll go ahead and give this an IP address of 192.168.7.2. You can see very interactive, very intuitive. Any object I select, I'm going to get the properties for that object. So I'll go ahead and add a couple of I/O modules. You should see a catalog here to the right. I have a discrete input module. Actually, it's a combo module, input and output module connected to the PLC. Select that module. My rail turns blue in every possible place that I can drop this module. I will drop it right onto slot 4. And there's my DIDO module, 16 points in, 16 points out. If I look here in my device overview, I can actually see the addressing that's been assigned to this module. It's at I0.0 through I1.7 and Q0.0 through Q1.7. And then I have one more module that's also a combo, and it is this module here, 8 in, 8 out. Drop that onto slot 5. Again, I see the addressing. If I select the entire CPU, and I can actually see each module and its addressing. Maybe I don't want that starting at 4. I can change that to a 2. So now my input is at on this module is at 2.0 through 3.7 and output of Q 2.0 through Q 3.7. So as simple as that, we've got our hardware configuration, or our local hardware configuration. I'm now going to add an ET200S node, which is our distributed I/O. And we have a couple of options on this CPU. We can distribute I/O over an Ethernet network, and that is our protocol with Siemens is Profinet. It's becoming an increasingly popular protocol among other manufacturers as well. So Profinet is the I/O protocol, and the PLC is the Profinet I/O controller. Every Profinet device will be an I/O device. Additionally, I could also distribute I/O via Profibus from the same processor. I have a Profinet I/O node configured here, so I will go ahead and add that node. So if you look right here on the right in the catalog, I can select Network Components, PLC, HMI, Distributed I/O. I want to pick Distributed I/O. The family of I/O is ET200S, Interface Modules, Profinet, and then I'll select my module. Happens to be this particular part number. If you mouse over it, you get the full part number or order number. You want to be sure you match that anytime you add a part to your configuration. Additionally, if I had a third-party Profinet device, I can install that GSD, which is the description file that allows me to add a third-party Profinet device. It's very similar to what you would do in Profibus or any other field bus such as DeviceNet. And this is the install generic station description file. That would allow me to bring in, say for instance, a Cognex camera that's on Profinet. And then I will see those devices populate down here under other field devices. Let's go I/O. Actually, let's look. I've got a couple on Profibus already dropped in. So here we can see I have a third-party vendor for I/O, and its devices show up here. And I could actually drag that device right out into my project, which I'm not going to use at this point, but just to give you an illustration that you're not limited to Siemens devices only on your distributed network. So back, I'll verify part number 3BA230AB0. Drag that device. Now notice it says not assigned. That means that this device has to be assigned to an I/O controller. In this case, of course, my I/O controller, I only have one in my project. I can do that a couple of ways. I can click on the hyperlink, select the PLC. If I had multiple, maybe I would want to do this more graphically. So I can actually select the port, drag right over to the Profinet port on the CPU, release, and it is now assigned. So this device is now going to communicate with this I/O controller. Additionally, this is a Profinet feature. It's really a name-based architecture. And what that means is I have to assign a name to this device. And in this case, the default name was I/O device 1. I'm going to change that to, for instance, JBox 1. Maybe it's actually residing in JBox 1. I want to make sure my name makes sense, because that name is going to be a part of my system diagnostic information that I don't have to program as strictly configure, but by naming it correctly, the message that pops up on the HMI is going to make a lot more sense. So if I want to configure this node, right now I've not added any I/O modules to this node, just an interface module. Simply double-click. That will take me up to the configuration screen for this node, and I can now add the modules that are going to be physically installed on this ET200S node. So I'll go ahead and grab the power module, and again, just simply matching part numbers as I need to. There's the power module. My first I/O module is a discrete input. 4-point standard module. It is this part number 131, 4BD01. Drag that guy in as well. Next is a 4 discrete output module. So open up the DO folder. And I have a 4BD30. Drag that one in. Then my last module is an analog input voltage module. And it is this exact part, 4LB02. If I want to see the addressing for these modules, again, right here in the device overview, I can see where the software automatically placed addresses. So for instance, my first input module shows up at I4.0 through 4.3, output at Q4.0 through 4.3. Again, I can change those as needed. For now, I'll leave those be. If I want to get back to configuring another device, and I'm in this device configuration view, simply hit my drop-down box and select another device. So that gives me some ability very quickly to bounce from device to device configuration-wise. And as you can see, everything is very graphically oriented, much more user-friendly. So I'll go ahead and save this project. And then the next step really is to add an HMI to this project. So to do that, I will double click right here on Add New Device, or I could go back to Portal View the way we did initially. But for now, I'll just double click on this guy, Add New Device. Last object I added was PLC. This time I want to add an HMI. And I have a 7-inch comfort panel selected, or actually connected. So I'll expand my comfort panels, 7-inch display. It is a TP700, and you'll notice I have two options for the TP700. It's the same panel actually. But if I'm mounting the panel such that I want to have it in a portrait view, if that's the way the panel will actually be physically mounted, I can configure it that way in my software as well. It's the same panel, just gives me a different way of configuring. Mine will be traditional, so I'll select this one. I have my Start Device Wizard box checked. I've never been a big fan of wizards, but this particular wizard I like very well. Select OK, and that will fire up the HMI wizard and allow me to connect that properly with my project. First step, PLC connections. I only have one PLC in my project, so I will select that one. And as simple as that, my HMI is configured to communicate with my PLC. There is no setting to change or adjust. Select Next. Screen layout. This is very handy. If you use the same header on your HMI from application to application, it remembers the last header and leaves it in place. So you can see I have my C&E Sales logo. I have my screen navigation as well as my clock, and that's exactly what I want for this project as well, so I'll leave that be. Move on to Next. Automatically can configure alarm screens or pop-up alarm windows. So I'm going to say I want to see pending and active events. I'm not so concerned about having unacknowledged. Screen layout. Generally speaking, I don't have my entire screen layout at this stage of the project, but I will start with a basic layout and then expand upon it from within the project. So for now I have a main screen, I have alarms, I have system diagnostics, and network layout. So if I wanted to change one of these, I could say Zone 1 layout. Simply click on the title and change the name. If I want to add a screen that expands just off of the Zone 1 screen, I could do this and say Zone 1 Tuning. If I want another screen off the main screen, just populate right here. So at this point, I'm going to get back to where I was. That's what I want at least to start with. System screens, I can get operating modes of the PLC, of the HMI, stop runtime buttons, control panel button, or I can actually turn those screens off one at a time. I want to leave that in place for now. And then the last step is the navigation buttons. I have a language switch button that I've left on the panel. Maybe I want to move that around a little bit. I have a stop runtime button. I could add a log on button, just some basic buttons that gives me a start on my navigation buttons. Select Finish, and this will have the HMI populated in my project, properly connected and ready to go. And it opened up my home screen. Notice the navigation buttons are semi-transparent. They are part of a global template. And then up here is part of a template as well, but this has actually been pushed right onto the screen. So I'll go back to Devices and Networks. I can double click it here, or I can use the quick taskbar, switch over to the device and config. And I want to check my IP addresses, see where these are located. PLC, I put it 192.168.7.2. The junction box, or ET200SIO, is at 7.1. That's where the software assigned it. I really want that to be at 7.4. And then the HMI, I select its Ethernet port. It's set for 7.3. Actually, I want the HMI at 7.4 and the junction box at 7.3. So can't have two IP addresses in the same range, so I'll change that to a 1 temporarily. Switch back to the HMI. Change that to a 4. And then change the junction box to where I want it to be at 3. Also note with the Ethernet address on a Profinet device, such as this device, Profinet I/O device, the I/O address is actually assigned, just trying to find that parameter for you, is actually assigned via the I/O controller. So what that means is when this device has a name, in this case JBox1, the PLC or the I/O controller will actually assign the IP address to the device. Additionally, with Profinet, you can have a setting within the PLC, and it is called, actually I need to go right on the Profinet port, Support Device Replacement Without Exchangeable Medium. What that means is if my Junction Box 2 ET200S node were to fail at some point, even without a memory card installed in the device, I can replace that device with a like device, and because I have that feature supported, exchange without replaceable media, that essentially means it will go out and find this device, match it up with the previous device, push down the name and IP address, and within about 10 seconds be back up and running. No configuration necessary, no software, no laptop, just simply replace the device. So it's a nice feature within Profinet that the processor takes advantage of. So at this point, my project is pretty well configured. I haven't got a program in it yet, but I'll go ahead and demonstrate a download to the PLC. And before I do, I want to show the advantage of a library. So I'm going to do, I configured that entire project, but what I want to show is that I've backed up a project, just the configuration alone. I want to show how I can take a blank project and bring that in. So if I've developed one machine, I want to bring in a configuration that I've already developed. So everything that I just did, I don't have to do each time I do a new machine. So I have here a blank project with no devices. If I double click on Devices and Networks, it'll take me to that blank network view screen. And I'm going to open up a previously created library. I can do that by selecting this Libraries tab. Select Open Global Library. And I've created this webinar library. Now if I expand this library, I'll see the objects that I've backed up. Here I've backed up a single screen, I've backed up a single node, and I've also backed up the entire configuration. So if I take this entire configuration and drag it to my configuration area, it's going to populate my configuration area with every device that I had previously configured. So to take a moment while it drops it in, obviously you can see how this would save a fair amount of time on a standard configuration where I just don't have to go through the steps of configuring this guy again, or I don't have to open up a previous project and start deleting things out. I can simply pull the library right in. Here we go, and here I have my PLC, my HMI, my node of I/O, as well as my switch. I actually have the switch in the configuration. So when I'm dealing with a Profinet network, before I perform a download, I go out and make sure my devices have the appropriate name assigned. I mentioned that each device has a Profinet name. So to do that, right-click on the Profinet network, select Assign Device Name. And I'd like to point out that this webinar, if there's a step or two that you miss, you can certainly ask questions, but we are recording the webinar, and we'll make that available on our website, www.cesales.com. So you can get a copy of this webinar and walk through these steps again if something went by a little fast. So right now you see the hourglass that's going out and searching for the device names. Here I've checked the box, only show devices of the same type. So it's looking out here, sees the switch, the Scalence X208 switch sitting at 192.168.7.1. That's actually exactly the way I want it. Same name. I want to check that I/O node, ET200S-1. And sure enough, I see it out there with the same name, ET200S-1. And that's fine. If I needed to change the name, I would select the Assign Name button here. So I'll close that. This is ready to go. Now if I want to download to the PLC, notice if I hit the download button, it really depends upon the object I've selected in my project. If I've selected the HMI and I hit the download button, it's actually going to download to my HMI. And again, this is the power of having these guys all in one project. My PLC over here in the project tree with all of the PLC parameters in the program. And there's the HMI with all the HMI information, screens, runtime settings for the HMI, connections, recipes. So it's the power of having this in one software, and we'll explore that just a little more here in a moment as well. So I'll select the PLC, select the download button. Now this is another feature with the software. If I did not know the IP address of the PLC, then it would actually give me the opportunity to check this box, show all accessible devices, and I could find the PLC even if I'm in the wrong subnet. So if I'm addressed on my PC at 192.168.1. something, I'm not in the correct subnet to communicate with this PLC, which is at 192.168.7.2. However, by clicking the Show All Accessible Devices button, it will search for all devices that I am connected to, regardless of IP address. So this is the correct CPU. I will select Load. And this is the download screen that will download to my CPU. Now you won't be able to actually see the CPU, but what I can do with the HMI is initiate the runtime simulator so you can see what the HMI looks like and the programming that we've created, how it interacts with the PLC. Select Load. And the PLC is in good shape. If I want to double check the PLC, let's see if it's online and happy. Select the PLC, select the Go Online button, and I should see the status of my network. Now you can't see this happen, but I'll go ahead and create an issue. Actually, I do see. I have a Profibus network configured with nothing attached, so I really need to delete that network. But other than that, we see everything is in good shape. If I create a fault, I just created a fault on my ET200S node. You see this pops up with a fault message. And then I'll get into a little further. We can see exactly what that does. And here we see I have a problem out here on my 4 discrete input module. So I'll put that guy back in, and we should be in good shape. And back we go. So I'll go offline with the PLC. And I want to look at the PLC programming a little bit. We haven't looked at that yet. If you're familiar with Siemens, it is a structured programming environment, meaning each block is its own piece of code. It is reusable, it is portable, and it must be called from a block that is being scanned. The main block that gets scanned cyclically is OB1. Additionally, we can have hardware interrupt blocks that get called when there's a particular event on a piece of hardware, such as an input. We can have diagnostic interrupt blocks. We can have cyclic interrupts. That's probably the most common, where we run a cyclic interrupt that runs at a particular interval. All of this is possible, of course. So at this point, I have these programming blocks, main OB1. If I double-click on main OB1, I have a little bit of programming in main OB1. So here I've created a switch. It's actually a hardwired input switch. I've also got an HMI switch in parallel. It's basically just a start-stop circuit. But I'll go ahead and program yet another circuit so that you can see the power of the software. I want to add a new programming block. This is the same as adding, if you were in the world of Rockwell, adding a routine. I will add a simple function, call it simple start stop. Program it in ladder. I have the option of programming in a function block diagram, statement list, or even source code language, which for those of you that have ever used that, that's like Pascal. Most people, of course, stick with ladder. So I have a network or a rung, an empty network. To program a simple start-stop, I have my user-defined or my favorites, really, favorite instructions. This is a modifiable list, so right now I could pull those, any one of these instructions, for instance, the bit instructions, out of the bit logic operations. If there's a particular instruction that I like to use a lot, I can add it. So for instance, I see I don't have my timer in here. So maybe I want a timer on delay. I'm going to use that a lot. I can drag that right to my favorites. And that's configurable. I can remove that object as well if I want. That gives me the ability, of course, to program much faster, and this favorites bar, very quick, very easy to use. So I'm going to build a simple start-stop circuit. Click on a normally open contact, drag it right to the network. Normally closed contact, drag it to the network, and a coil. I want to have a latch or CLN around the start, so I will add another one, and notice I don't even add the branch. I simply drag the contact to the location, and then I connect my branch. So I have no names on my addressing or tag names. This is a truly tag-based software. There's always going to be an address associated with the tag, however it is a tag-based software. So if I want to configure a new tag, I will call this HMI switch number 3, since I have switch 1 and 2 already configured, as you can see. We'll call this one HMI switch 4, and we'll call this one output 4. Want to add output 4, drag it over to my branch. Now notice none of these are happy. The network has a red X. I have red squigglies. Not good information there, so I have to actually define the tag. Very similar to what you've done in other tag-based software. I can either right-click on the tag and define tag, or in this case I can actually right-click on the network define tag and pick all of these tags at once. It will automatically select open unused addresses. So I'll leave those be at M0.4, 5, and 6. Actually, I may make this an output on the PLC, but I'll leave it at M0.6 for now. So now you can see the network is happy. You have both addresses and tag names available. It's ready to go. I've got this again located in this routine FC1 simple start stop. For that routine to execute, it has to be called from another routine that is being executed, such as the main. So to call it, very simple. I don't have to use any particular instruction. Right click here, insert a network, and I'm just going to drag this FC right out to the network. So that's it. That's been called, and at network 4 and OB1, FC1 will get executed. Now when I choose to download, you'll notice this will not take my processor out of run mode. It's simply going to download. It's going to download the new information. FC1 and OB1. Say OK. Select load. And that's now running. So if I went online with this particular block, select the monitoring on-off button, and I'll see this block executing live. And I could, since it's not programmed anywhere else in the PLC, I could actually modify this right here and actually turn on the output. HMI switch 4, modify that to 0, and there we go. And turn the output off. But what I really want to do is program that from the HMI or control that from the HMI. So I'm going to pop over to my HMI. I'm going to leave this open. So in my project, expand HMI, expand screens. I'll open up the home screen. I have some pre-configured devices, an analog gauge, so I will add in this next set of switches. These are library objects, so those are pretty handy. So for a start-stop, I could program a button and give that all the properties necessary to turn on those HMI switches that I just configured. Or I can select a pre-configured object out of the library, which a lot of times that fits the bill. So I switch to my library tab, select buttons and switches, and we'll go to toggle switches and say, alright, I could actually choose a different type of switch. We'll go to slide switch, or I guess we can go to a push button switch, make it a little more enjoyable. Actually, it's probably the wrong choice here. Let's go to this guy right here. Just scratch that. Alright, let's go back up to Toolbox and we'll do it the long way. Okay, so here I am with a push button. I'll give it HMI switch 3. I want, when I press this push button, I want to see an event take place, so I select the Events tab, press. This needs to be a momentary style button, so I want it to edit a bit, and I want it to simply set the bit while the key is pressed. In other words, a momentary operation. And then I want that to affect that tag that I just created over here in my logic routine. And notice how I can switch from HMI screen to logic routine without switching software, just switching tabs within the software. So what I'm going to do is take this window, this logic routine, and float the window. And that allows me to have this window just, as you see, floating. And I'll go back to that Events tab, and I want to take this tag, HMI switch 3, and add it to that button. So I'll drag it right into the tag field. So obviously that's a pretty powerful feature, in that now the button is configured to energize that bit. I didn't have to even go browse for the tag. I simply took it right out of logic and dragged it right to the button. I want to create another button that does the stop. Right click, copy, right click, paste. We'll call it HMI switch 4. And again, this will be a momentary button. It's simply a stop button. I go to the Events tab. It has HMI switch 3, which is the wrong address. I want it to be switch 4. So again, float my logic window, select HMI switch 4. Gotta get to the right area here on the button. There's the event, and drag HMI switch 4 into that address field. And now it has been updated. Maybe I want an output light, output indicator. There we go. So here's an indicator. I just want that to come on or off based upon the state of output 4. So I'll switch back to that screen. To animate this object, I can do the same thing with the push buttons. For those of you that have used WinCC Flexible in the past, this operates very similar to WinCC Flex. It's really almost identical in how it operates as far as properties. So that's a very easy transition. Select the object, select the Animations tab. So I want this to appear differently based upon the state of a tag. So on the Appearance animation, which tag do I want to change the appearance? Well, again, that's going to be the state of output 4. So we'll drag the output 4 tag into the tag field. Back to the screen. So we'll say, okay, if it's a 0, I want the background color to be actually dark gray is probably good. And if it's a 1, I want the background color to be green. So now this object will animate based upon the state of output 4. So now I save it, and I can download to this HMI, and that, just like I did the PLC, select the download button, selecting my path like this, I only have to do that the first time I download to an object. And load. Now you can't see the HMI changing state, but it is downloading. What I will do is start up the runtime simulator on this HMI so you can see how this operates. This is something you can do during development. It's built into the software. Gives you the ability to test your HMI with your PLC without having an HMI physically hooked up. So you can see there I'm in that dark state. And I can actually go over here to my PLC, monitor the PLC, And then here I see HMI switch 3 and switch 4. If I energize switch 3, you can see it change state. There's my output 4. Switch 4 works very well. So you can see that happened very quickly. Integrating was very simple. Didn't have to create any particular tags in the HMI, only create them in the PLC, and then use what I need in the HMI. So this way the HMI is not loaded up with every tag from the PLC. It's only using the tags that you need. So you develop the screen object, then you add that object, the tag parameters to that object from the PLC. Because this is all one software package, it's a simple thing to do. There's no importing and exporting. You can drag right from logic. You could drag from the tag editor as well. So if I'm looking at my PLC tags, I could go to Show All Tags, and I could float this window and start dragging these tag objects right into the HMI screen. So I wanted to touch base on system diagnostics, and what system diagnostics are going to allow us to do is pick up any event that occurs out here within this PLC's configuration. So every object you see here is as a part of the PLC's configuration. That means I can actually have alarms coming from my Ethernet switch, since this is a managed switch, from my I/O objects, which in this case is my, I only have the one distributed I/O node. All of these objects have diagnostic information, and to gain that diagnostic information programming-wise, I have to do a couple of things. One, in the PLC, I have to go to the properties of the PLC and device configuration, select the system diagnostics, and check the box, activate system diagnostics for this PLC. That's all I have to do, and you'll notice when you have a download, a full download, that it takes a little longer because the system diagnostics are getting downloaded also. And again, I see maybe a couple of folks with hand raised, but if you have any question, please feel free to add a question in, and I'll go ahead and pop over to the HMI. So how do I view this diagnostic information in the HMI now that it's been programmed in the PLC? And it is programmed when you do the save and download to the PLC. So I'm going to open up my home screen, and I have a link pre-configured here to my alarms page. If I double click on the alarms page, this is as simple as adding an object. If I look over here in my elements, I have down here in the controls area an alarm view. So when I add the alarm view object over to the screen, it becomes this particular object. I'll maximize this so it's a little easier to see. And then to configure this object, again, just like every other object in both the PLC and the HMI, I can double click on it or simply look at the properties. I can go ahead and select the columns. What do I want to see up here? I'm really not interested in everything. I just want to see time, status, alarm text, date. However, you can create different groups of alarms, and when you create different groupings of alarms, you can actually display which group the alarm came from. You can configure your alarm views to display only one group. So you have several options. But this is just to display what options or what pieces of information with the alarm that I'm going to see. The other thing I have to configure, if I go back to the general, is I have to check these two boxes. System diagnosis events as well as system no acknowledgement. Those two boxes are what are going to bring in those system messages from the PLC. Obviously, that's a very quick option. Nothing to program, simply add my alarm view, check these boxes, and that will now display diagnostic information, which I will demonstrate here in a moment. Additionally, there's a system diagnostic view. So I've added that here to this page 2, system diagnostic view. Again, just another object to select. If I look down here in my controls, there's this little stethoscope object, System Diagnostics, and this is going to allow me on the screen, my HMI screen, to actually drill into each portion of the configuration. And again, the parameters on this object allow me to go as far as I want to go, essentially. In this case, I want to see the status. Of course, I need to see the name. I want to see the slot type. I want to see the actual part number of that device. Again, very effective. So if you had a particular module fail, and we'll show this, you'll see the part number for that module. Very helpful. So I'm going to go ahead and demonstrate what happens here when we have a fault. So I go into the runtime simulator. And I will say that system diagnostic view, there's one icon that for some reason does not pop up quite the way we'd like to see it on the simulator. It works fine on the HMI. Just testing to make sure I'm online. So at this point, I'm going to generate an alarm out here on my, I'm going to say I lost the entire node, ET200S node. I think I have that in there correctly. Oh, I'm in the wrong project. Look at that. I apologize. I'd forgotten I'd opened up a different project there. That wasn't the current information. Wrong one again. How about that? Alright, let's see what we have here alarms wise. Double check that configuration. System events checked. Double check alarm settings as well. Okay, all things are good. And just to be sure my system diagnostics are enabled, I'm going to go ahead and download to my PLC again. Those are enabled. And I'll download everything to the PLC. You notice this download takes a little longer because it does actually generate, as you can see, the system diagnostic blocks, and then it will download those to the PLC. And it's those blocks that are going to provide all the alarming information to the HMI. They are actually programmed blocks, but the PLC takes care of that configuration. So basically, if you add a new node to this configuration, you want to be sure that you download again the entire hardware config. So it's going to load the information, finish. And my PLC is back to green lights. Now I'm going to Just make sure this is all ready to go in the HMI. I want to be sure it has current information. If I did a download to the HMI, it would certainly do this along the way. Because I'm running Runtime Simulator, I wanted to manually rebuild it to be sure it had current information. And I'm going to go ahead and add to that page, as I mentioned, the system diagnostic view. Properties, columns, I want to see just about everything here. Okay. Okay, general. Should have it all. Double check the alarms view. Make sure that that's still configured correctly. It is. Okay. Now I'll fire up the Runtime Simulator for the HMI. And should still be operating. We are. Very good. There we go. So this time, actually, it got overwritten for a second there. I generated an alarm. There it is. This was name JBox1 on the node. If you recall, that's the name we gave the ET200S node early on. I changed that in a later project, but initially that's what we had, JBox1. So it's giving me a pretty good description, module removed, what the problem is. Normally that's not going to be the problem, but it gives you a good indication. I'll put that guy back in. What if I lose the entire node? I'll go ahead and pull the entire node off. Actually, I think I got the wrong one there. So let's go over to the diagnostic view. Here we go, alarms. And actually I want to go to this page 2 where I put the system, actually system diagnostics. So now if I create a problem, you'll see it shows up here in the system diagnostics view. I can select the object, drill down into the object, continue to follow the object's path here, the rail on the object, or essentially the back plane. There I see PLC1. There's a problem on PLC1. The I/O modules are fine. Drill into PLC1. There I can see I have a problem out here on the Profinet interface, which is where my Profinet I/O network is. Here's the Profinet I/O system. Keep drilling in. And it's the problem out here on object number 1. And sure enough, JBox1. And there's my module that's faulted. So again, you see the depth that I got of diagnostics here without ever having to program anything. Additionally, let's say this module is actually bad. I actually have a full part number right here on the module. So again, I didn't do anything to get to this point other than those check boxes you saw me select. No programming, just the configuration. So now if I had this module fail, and I have someone who doesn't have a laptop to get online with a PLC out on the floor, they can simply drill right into the HMI just like we did, find this problem, there's the part number, pull that part number out, and this is slice-based I/O, so it's very simple to replace, reinstall the module, and you're back up and running. Pretty simple to do. And that really is as far as I wanted to go today. We could certainly go farther, but we're out of time, a little over actually. If you have any questions, feel free to ask. I'll stay online here looking for questions. Additionally, we will post the recording of this webinar, so that if there are any steps you missed or you want to go back and look at, you can look at this file. It'll be in a WMV format, so a simple Windows Media Player will play the file. So with that, I thank you for your attention, and I will remain on the line for any questions.